Hello class, let us take another problem. In this problem, what is given to us is, take on the page here. Better I take notebook. Yeah. In this problem, what is given to us is, there is a block which is of certain mass, capital M. And there is a particle, small particle, of exact same mass as the block. Now this system is placed on a frictional surface. Therefore, what we analyze is, as the block is moving to our right, there's a force acting on the block which is in the backward direction. So force acting on the block and it is in the backward direction. Just a moment. It is in the backward direction, which I show this way. It's highlighting the force. Yeah, I can take the board marker, but force of habit. Okay. Normal, the author has said, from ground passes through the center. So we have to keep normal passing through the center as per the ask of author. So if normal is to pass through center of block, then what should be relation between H, which is this, and L, which is this? What should be relation between H and L is being asked by the author. Okay. Now for this, so what I suggest is, try draw free body diagram for the block. So what will be free body diagram for the block is to be checked first. How to draw free body diagram for the block. What are the forces acting on the block? Those forces are to be taken in account. Only then we can draw free body diagram, goes without saying, right, class? So given to me that I have to draw free body diagram, I try to draw free body diagram for the block. Two forces are to be marked without much of deliverance. One is normal as per the ask of author, and the other is empty. The force which will act on it is the friction, and it is in the direction backward, Fk, as it is rubbing the surface. Then there will be a force from mass which is even with mass of its own, and that is N1. Generally, students are content with these four forces. Of course, there is one more which is, I would say, occulted, which is somewhere camouflage. I will try to surface that force for you. Think of you being on the block. And being on the block, you are making an observation vis-a-vis this particle. So the frame that you are in is accelerated, and as it is accelerated, you will apply a force on this particle in the direction opposite to acceleration. Friction is backward, so you are accelerated backward. Your frame is accelerated backward. So on this particle, if you are to draw a free body diagram for this particle, you will apply a force on this particle, pseudo, which is in the forward direction. Right. I'm showing it by a different color because this is for the free body particle, I would say. So I'll show you by a different color. This is the color I'm picking. For particle, FBD for the particle. So there is a force in this direction. Okay, I take me a bold one, otherwise there will be concern that I didn't stick to what being asked. I shouldn't be volatile of it. So this is the direction of force on the free particle pseudo force. I'm sorry, I'm calling free particle on the particle pseudo force. But the body is at rest, the particle is at rest as viewed by me. I'm on the block, I am put up on the block. So there must be a force to counter this force, and that force must be applied by none other than the element which it is in touch with, which this particle is in touch with. And what the particle is in touch with is obvious, is the block. So there must be a force which is courtesy friction, we know, to oppose pseudo force to make good my observation, to vindicate my observation of this particle being at rest. It's being told in the problem that the particle is stuck to the block. Now coming back on FBD for the block now. So there must be a force. This force is applied, this one is applied by the block on the particle. So there must be a force by the particle on the block, which we are to show. We are showing it this way. Back to the color of the block. Right. Now what I do, I write torque equation from center of mass of the block. F is to produce what torque? F into h, which will have a sense clockwise. H by 2, right? F into h by 2, which will have a sense clockwise. Then what we have next, think about it. We have Fk as well to produce clockwise sense. So plus of Fk into this time, what will that be? L by 2, correct? Or H by 2? I won't tell you, you'll have to tell me rather. H by 2, right? Correct? H by 2, both H by 2, and both are trying to rotate it in the sense clockwise. What about n prime? N prime is trying to rotate it anti-clockwise. So negative of n prime, and the distance here will be again H by 2. No, L by 2, right? You're right. They are to equate to I alpha, alpha being 0, so they are 0. Now what about n prime? N prime we know is equal to mg. We'll replace for n prime. What about fk? Fk will be equal to mu k into n. So replace it by mu k into n. What about f? What is f over here? F will be mass into acceleration of the frame. Now, how do we calculate acceleration of the frame? The frame that we are put up on, if we take entire of the system to be a unit having mass 2m, then Fk into normal, which is 2mg, should be equal to 2m into a. Right? Mu k into normal, Fk is equal to mu k into normal. So once I have taken Fk, this I will have to remove and then place mu k, then place mu k into normal. Normal means total body, entire as a unit, 2mg is equal to 2m into a. So a is what to us? A is equal to mu kg. If a is mu kg, then F should be equal to m, the mass of the body, into mu kg. Right. So far, it's predictable. Now, placing them one by one in equation 1, we get m, the mass, mu k into g h by 2 plus mu k into normal. Now from ground will be equal to mg plus n prime, which again is twice of mg. Okay, into what class? Into h by 2. And then we have n prime is mg, so mg into L by 2 is equal to 0. We can get rid of mg, given to us mu k is 2 by 3, so 2 by 3 h by 2 plus 2 into 2 by 3 h by 2 minus L by 2 is equal to 0. Gone these, what we are left with is 2 by 3, so this gets us 2 by 3 common, 2 plus 1, 3. Correct. So we get 2 plus 1, which is 3, and 2h by 3, so 2h minus L is equal to 0. H is equal to L by 2. Correct. Good question from the Super Bash package. Thank you yet again for indulging me. See you at the other end.